Hello and welcome back. Today I will tell you about sedimentary rocks. We already know that there are three major rock types: magma rocks, sedimentary rocks, and metamorphic rocks. Sedimentary rocks contain most oil and gas deposits, which means that petroleum engineers take special interest in this rock type. Besides mineral composition and genesis, rocks differ from each other in structure, texture, and shapes of geological bodies that they build. Rock structure is determined by size, shape, and mutual connection of mineral grains. Rock texture or microstructure is determined by geometric relations between mineral grains and relationship between the materials of which the rock is composed. Sedimentary rocks occur as layers characterized by bedding or stratification, contains fossils, and some of them may be built interior of shells. Depending on formation conditions, three groups of sedimentary rocks are determined: clastic or heterogeneous rocks, chemogenic rocks, organogenic rocks. Clastic rocks are composed of accumulated fragments of pre-existing rocks. Clastic rocks are the most common on Earth. Based on the size of the fragments or class, we distinguish coarse rocks, sandy rocks, silt rocks, and pilitic rocks. Rock types differ from each other not only in class size, but also in class shape, round or angular, and presence or absence of cementing material. All these and some other parameters influence the so-called reservoir properties of the rock, which will be covered a bit later. Organogenic rocks originate from various organisms, mostly shells of marine invertebrates. These are limestones, shellstones, chalk, coals, oil shells, etc. Hemogenic rocks are formed through chemical precipitation of substance previously dissolved by water. Precipitation typically occurs in lagoons and lakes. Hemogenic rocks are product of environmental changes, chemical reactions of various solutions, and evaporations. They include such minerals as dolomite, rock salt, gypsum. As for the texture or microstructure of sedimentary rocks, it is very important for us to understand the capability of rock to contain liquid hydrocarbons or serve as an impermeable barrier. In other words, to form an oil or gas field. The major components of rocks are framework grains, matrix, cement, and pore space. Framework grains are sand or silt grains that build a rigid frame capable of preserving pore space which will contain hydrocarbons. Matrix consists of finer material that surround the coarser grains, filling the space between them. So, what does it do? Right, it reduces the pore space. Cement is a chemically precipitated material that fills the space between rock grains and binds them into a solid mass. Cement may form in place or may be brought from other areas in water solution. The most common cements are earth silicon, carbonates, various iron oxides, barite, gypsum, anhydrite, sulfur ore. Why it is so important for us to know the cement type? Imagine what we develop an oil field and decide to use acid treatment to stimulate oil production. If we know the cement type, we can select the right acid, what will be the most efficient for this rock. Pore space is void space between framework grains, the very space that contains hydrocarbons. Thus, the larger the pore space, the more hydrocarbons may be accumulated in this rock. The most important textural components are grain size, sorting, roundness, shape, packing, and grain morphology. Grain size is the most obvious characteristic. Based on this property, geologists distinguish coarse rocks, sandy rocks, silt rocks, and pilitic rocks. Sorting reflects a dynamic process. Clastic rocks built of grains similar in size under certain conditions are called well sorted. Most clastic rocks are built of grains that vary in size, so depending on size variance, they are regarded as poorly sorted or very poorly sorted. Geologists can tell if the rock is well or poorly sorted by looking at it. We also need to mention that reservoir properties of rock depend on sorting directive. Grain shape describes the geometry of sedimentary particles. It depends on sphericity and roundness. Roundness is the degree of angularity of a sedimentary particle. As the grains were transported and deposited, they were suffering many kinds of abrasion, from gliding against each other from water, wind, temperature, etc. The longer a grain traveled, the smoother it became because of this abrasion. A smooth grain is called rounded. Well-rounded grains build rocks with good reservoir properties. Packing describes spatial arrangement of grains. It is obvious that closer it is to the ideal cubic packing, the better rock reservoir properties will be. That was a brief and general description of rock characteristics. See you!